Yes. Okay. Okay, now the recording started. All right, so welcome everyone. I'll spend the next like 50 minutes to an hour or so going over December 2021 bronze questions 1 and question 2. So during this, I'm going to go, like I said earlier, I'm going to go over the thought process behind answering the question, and then I'm going to code it with you if there's time. I think there'll be time, but you never know. All right, so this is so this is problem number 1. I sent you the links on the Discord so you don't have to go hunting around on the USACO website for them. So we have here, Farmer John has recently acquired N new cows, 3 to 5 times 10 to the 5th, each of whose breed is either Guernsey or Holstein. The cows, you know what, the text is really small, so let me zoom in. The cows are currently standing in a line, and now Farmer John wants to take a picture of every sequence of 3 or more consecutive cows. However, he doesn't want to take a photo in which there's exactly one cow whose breed is Guernsey or exactly one cow whose breed is Holstein. So, this might be a little bit difficult to understand. So one thing that you can do is draw it out. So if you're, what, how is this supposed to look like? So I'm just going to represent them with G's and H's because that's what the sample input does. So you might as well do that. So you have G, H. So I guess it might either look like this with a bunch of H's and then a G, or it might look like a G surrounding a bunch of H's like that. And there appears to be something wrong with my Zoom. So let me close that. Yes, my Zoom sometimes malfunctions. So yeah. So we have that. So we have G, G, H, and then G, and so on and so forth. So you might notice here, something that you might notice here is that you could see that there's only one G. Obviously, that's what the problem is telling you, but they're surrounded by other H's like that. So that might be something interesting for you to take a look at. Maybe that's something interesting that we might be able to leverage later. So if you write these things down, you might notice some patterns going on here. So he thinks that the cow would feel lonely, blah, blah, blah. Says he throws out all of these so-called lonely photos in which there is only exactly one Guernsey or exactly one Holstein. So given the lineup of cows, please help Farmer John determine how many lonely photos he will throw out. 2 photos are different if they start or end at different cows in the lineup. So that means that he could have the same arrangement of cows. So like, let's say G, G, H, G. He could have the same arrangement. It just means that they can't start it or end at the same place. You don't have to like disambiguate it. You don't have to be like, have I seen this picture before? Because unless they start at the same cow, they have it. And the first line of input contains N. The second line of input contains a string of N characters. The ith character is G if the ith cow in the line is a Guernsey. Otherwise, it'll be an H and the ith cow is a Holstein. Just out of curiosity, is everybody able to see the screen that I'm sharing? Just want to make sure. I have to open up the chat. Okay, perfect. Okie dokie. So so you have to think of, so when you start start writing this program, right, the simplest way you might imagine solving it is that we go through each of the characters in the string, we try out a string, and from each character we try a string of length 3 and see if that hits if that's it. And if you try a string of length 4 and then you check it, and if you try a string of length 5 and then you check that. So that's an O of n cubed solution, because if you think about that, you have to loop through this entire string to find it with the starting character, right? So you start here and then you start there, and then you have to go, so that's n, right? Because there's n characters in a string, we don't know how many there are. And then from there, we have to figure out strings of length 3, 4, and 5, which is another n. I mean, it's a little bit lower than n, but like if there's 50,000 letters in this string, obviously there's not that much difference between 50,000, like 49,997. You could just call that n. And then within each string, we have to figure out like, is this a valid solution? So like then you have to loop over all the characters, and we don't know how many characters there will be, so we call it n times n times n, which is of course n to the third. And that's not very good because of course we have 50,000, possibly 50,000 letters. So you don't want to, yeah, you don't want to have an n cubed solution. You could see down here that some of the test cases are smaller, like this one is 50 and this one is 5,000. Test case 11 has no other constraints, so they could be really long. And then some of these you might have to use the long type 4, which is 64 bits. You don't use that a lot, but sometimes they do kind of point it out, so that, just keep that in mind. Ideally, you'd want to do all of them, so don't be like, you know what, 1 through 10 seem pretty good. I don't want to do the other 15. Try to aim for all of them because you never know when you'll need the points. All right, so we've established that the simplest solution is an n cubed. So it's just the most obvious way of doing it. It's, yeah, like there's not much thinking involved. But if, look, obviously n cubed is not that good of a solution, right? So you want to make it slightly, you want to slightly optimize it. So one thing that immediately comes to mind is obviously there's no way, if you just think about it for a little bit, it's not that easy to remove the first loop, which is to go through each character in sequence. It's not that easy to eliminate the fact that we have to look through each character in sequence, but perhaps there is a way for us, or like get a substring of 3 and a substring of 4 and a substring of 5. But if you think about it, right, there's a lot of repetitive work that we're doing because a substring of 3 by necessity contains a substring of length 4 and then a substring of length 5. So basically you're doing the same work over and over again. You're just never caching it. So that gets very annoying. And obviously that's a waste of time because if you're analyzing the same substring over and over and over again, then obviously that's kind of a waste of time. So if you think about it, right, let's say that we have, so remember the thing that we made up here where we're like, we have G and then H. So it has to be surrounded on all sides by G, but not necessarily, right? It could be like G, G, and H. That would work. But if you think about it, right, the requirements for a string to meet this criterion is that first there's more than 3 because it says it up here. Where is it? It says, let's see, 3 or more consecutive counts. So the first criteria is that a string has to be 3 characters or longer. So obviously we have that. But it could be so basic, so that would be our first criteria. It's I, or I don't know, I'll just call it L. L is greater than or equal to 3. The next criteria is that there's either one cow whose breed is Guernsey or exactly one cow whose breed is Holstein. So we'll say that. So we'll have to keep account of how many G's and how many H's are in there. So it looks like here we have, let's see, we have one H. So if we had just analyzed the string, we would say there is, let's see, one H. So H is equal to 1. The number of H's will be in this lowercase h variable. This G over here would be in this lowercase g variable, and we'll just call it 2. So obviously this fits our criteria, so we could add it if the number of lonely photos goes up by 1. Let's pretend for a second, right? We add another G to the end. So in the n's cubed version, we would have to loop through each character again. So we'd have to see that there's count 2 G's and there's 1 H. But if you think about it, we've already done the counting for these, right? We've already counted the G, G, and H. So there's no reason for us to recount everything because we've already done the hard work. So why not, when we're looping through the string a second time, why don't we just loop through it? We don't have to reanalyze it. We already analyzed it up to a certain number of characters. We're just adding one character to the end. And so we just add it to our So we just add it to our total. So our G goes up from 2 to 3. Because remember, they're not asking us to keep track of which pictures are added to the total. They're just asking us how many total pictures. So if you overwrite the G equals 2 to a G equals 3, there's not much of a difference because they're not asking you like, oh, can you print out all of the valid pictures that, all of the lonely pictures? You don't have to do that. So that saves you a significant amount of time because now you don't have to loop through the string. Imagine like your string was 50,000 characters long. And then so you're out here like, oh wait, I have to loop this whole string another 50,000 times, which is obviously not very fun. So we have that. Obviously, this would still work because L is greater than or equal to 3. G is now equal to, H, either G or H is equal to 1. So, okay, so that's very nice. So let's say that we added another G to the end. We don't have to recalculate everything because again, that would be a waste of time. And one thing you always have to pay attention to when you're programming and you're optimizing things is never to do the same thing twice if you can help it, because there's no reason to like recalculate the string again because we already have G equals 3, H equals 1. So why not just turn this into 4? This still fits the bill. So we already have 3 pictures, GGH, GGHG, and then GGHGG here. So you could see that you save quite a bit of time if you do that. So there's a few optimizations that you could do. For example, like if there's an H, obviously we could abandon it because no longer does G equal 4 and H equal 1. Now H equals 2. So there's no way that this could ever be a lonely picture because there's 2 H's. So after you're done with this, just exit out. I mean, like you don't, there's no possible way that this will ever become a lonely photo again, no matter how many G's or H's follow this. So if you see something like this, you could just abandon it because there's no other reason for you to continue on with it. All right. Does anybody have any questions about this? No questions? Okay. So in that case, I will move on to the coding part. All right. So hopefully you guys have Eclipse running or something. I use a slightly different text editor because I'm low on RAM right now. And so the people in my class would know this, would have seen this before. But let us get started on this. All right. So there we go. Here's my little text editor. It does the same thing as Eclipse, so it doesn't look exactly the same. It doesn't have all of the bells and whistles. I mean, but this could take Java code. Eclipse could take Java code. It's pretty much the same. So this takes input through system.in. So make sure you know how to send in input through system.in. So I'm pretty sure you guys already knew that, but just in case for the people that didn't. So I'm going to call this lonely photo. So let's see, public class lonely photo. Make a class for this. Put it wherever your normal, like name it whatever your teachers ask you to name it. So like if they have a specific naming scheme, call it that. Like if they're like December 2021 bronze problem 1 underscore lonely photo, do it that way just so you don't get them confused, like just so you don't have a random class called lonely photo in your Eclipse. So we have public static void main string of args. So obviously we need a scanner. Sometimes scanners, it's a little bit slow because scanner is just a slow thing. There's really no way to get around that. So if you have a lot of line or a lot of inputs, it could be a little bit slow. However, we only have 2 lines of input. The second line could be a little long, like 50,000 characters or so, or 500,000 actually. I might be getting my scientific notation messed up. But in this case, I would say it's sufficient. So I'll put, oh, and I need to put in our imports, java.util, and then import java.io, and then we will put our scanner in equals new scanner system.in, like that. So obviously our very first line of input contains n according to the problem. So we'll do that, and n equals n.next int. Oops, and I have to save my file. I'm gonna do that. By the way, if you're coding with me and then you see something underlined in red, let me know so I could fix it. Oh, Kiara, if you don't know Java, then try to follow along in Python. The algorithm should be able to be implemented in any language, so Python, C++. It's just I'm the most familiar with Java, and a lot of the students here are also familiar with Java, so I'll do it. But you could, in principle, implement the same algorithm in Python. Yeah, so so this actually I'll comment it so it's a little bit easier to read. So this one is like and get and. So our next order of business is to read the string. So I'm going to do that string. So read the input string. I'm going to do s equals in dot read next line. Next line. There we go. And then let's see. So technically in Java or in Java, you don't need to have n because it's kind of redundant because s is basically, how long the s dot length is how long the string is, but you could certainly use n if you'd like. It's a little bit shorter than s dot length. So I will go over. So let's loop over it once, just like I told you earlier. We have to start on some characters, so why not start on the first one and move on to the second one, then move on to the third one. So I'm going to do that. And I plus plus. And then, so within each one, right, we remember we're not keeping separate counters for each possible string. We are keeping one counter for the entire string because we're going to read a 3-character long string. And then we're going to get a 4-character string and a 5-character string. And we don't need to reanalyze it each time, like I said slightly earlier. Int g equals 0 and int h equals 0. So we have for int j equals I because we want to start at that particular location and we want to go all the way up until j is less than n, and then we do j plus plus. So here's the thing now. I said earlier we start with 3 characters, and then we make it when we make it longer and longer and longer and longer. Unfortunately, here it's okay. We could make a string of 3 characters and keep adding stuff to the end. But if you think about it, then that requires string processing. We have to make it like append stuff to the end of the string, and appending strings in Java is not very fast. I don't know about C++, but in Java is not very fast. And if you think about it, why do we need to make a string in the first place? Because it's not like we're going to look at the string again. We're just looking at the characters that follow at the end. So what I'm going to do is, one thing that you might notice is that, actually, let me comment this, loop through the string, through each character of the string. And then these are our counters, G and H. And then we're going to loop through the remainder of the string. So obviously, if you think about it, right, G plus H has to be the length of the string. So we don't have to have a separate counter. I mean, you can if you want. You can have like a separate counter up here that's like int counter, like equals 0. You could do that, but there's no reason to, because if you think about it, G plus H is basically the length of the string because you can only have G's or H's. Like you can't have like W's. So if s.char of j is equal to G, then we make G go up by 1, just like we said, just like you would expect. And it does it for every single one. So like you don't have to technically add it to the end of a string. because we're just looping. We're not interested in like the content. We're just interested in the next character. So we're not. We don't need to build a string because we're not even going to look at the string afterwards. Otherwise, we know it's if it's not a G, then it's an H. So we do H plus plus. So how it works is that we will have. Remember, we will have two conditions. We have, two conditions. If the length of the string is greater than or equal to 3, which is, of course, G plus H greater than or equal to 3. And if either there's one G or one H, right? So if there's one G, or one G, or one H. And here it's important to remember your order of operations in Java, because if you just do this, like, oops, G equals 1 or H equals 1, it will assume this will happen first and then it'll do these. Whereas it'll be this and this have to be true or H could equal 1. So you don't want that to happen. So you want to parenthesize it. There we go. And then we have that. And obviously we need to have an answer. So answer variable. So you have and answer equals 0. Make answer plus plus. And then remember our escape hatch when we have like a really long string, right? We don't want to, when you have a really long string, like we hit another G or another H, we don't want to continue going on. So if the length of the string is, so if G is greater than 1 and H is greater than 1, oops, that's not how you write that. Then you do break because there's no reason for us to continue this. It's like if you know you're doomed to fail, then don't fall into the sunk cost fallacy. Like don't say, you know what, I started this, I have to finish it. You don't have to finish it. There's nothing else for you. Like if you're digging for treasure and you find a treasure chest and then you keep digging, that's kind of a waste of time. That's the same idea here. And by the way, if you need me to kind of explain this code again because you're not writing in Java, just let me know. And I'd be happy to do that. So I'll do system.out.println, which is answer. All right. Does anybody have any questions about this? No questions? Okay, so it's time to go and check it. And the way I do it, I run my code a little bit differently. And so like obviously we wrote the code. Now it's time for us to debug it in case something went wrong. I mean, I didn't intentionally put anything wrong in there, but you never know. So I do everything on the terminal because again, Eclipse and my RAM don't have the best relationship. So I do everything on the terminal, which lets me do the same thing that you do in Eclipse, like the run button in Eclipse is the same thing as me running a command here. I just wanted to show you the output. Like you don't have to do this on the terminal. I just do it because I just do it. That's the best way to put it. So I'm going to, and then so you should set up like your environment in the way that you always do it, like paste in your system.in, load photo.in. And then so I will run the code. You can see it on the terminal. Don't get hung up on like, oh, what is this guy doing? But pay attention to the output. So I will do lonely. And then it will run. It looks like there was a string index out of bounds. So when you see this kind of error, don't have like a heart attack. Think, okay, how am I gonna, what is wrong with this? How am I gonna fix it? So obviously it looks like our error was on line number 24. I'm gonna take a look at that. Let's take a look. Line number 24. Over here, s.charat. It looks like it should be fine. So I'm going to print out system.out.println s. so I can see what is happening. It looks like it did not print anything, which is very strange. I'm gonna try n.next. Let's see what happens. Okay, it looks like it wasn't next line, it was next, which is very strange, but yeah. So whenever you see errors like this in scanner, it's fun. It's fun to play around with some of the scanner methods. Like if next line doesn't work, try next. Because the way you could tell is that there's nothing wrong with this, right? There's nothing wrong with the fact that j equal I. So it looks like nothing is wrong. Like then don't waste your time on it. Look for where S came from. So take a look at that and analyze it. Looks like our sample output was correct. So I'm going to, so does anybody have any questions about this? I will have to log in to my, I will have to log into my account to have this run. So please stand by while I find my username and password, because unfortunately they're not saved on Chrome for some reason. I have to go search through my email to find it. Okay. Okay. Okay, I'm trying to find out where my USACO email came from. Where is the USACO email? Okay. Okay, there we go. I found my email. So I'm going to now log in and then test it. Uh-oh. Okay, looks like I saved it. I'm going to run it. Let's see if that works. If there's a timeout, then we will have to rethink about our solution. But again, if you're following along in Java, that's great. If you're oops. If you're following along in Java, that's great. If you have Python, then just select the correct version of Python. Or if you're following along in C or C++, then you do that. I'm going to oops, not my I'm on the wrong folder. So you select the Java class, you have to know where your Eclipse folder is. But I know most of you know that, but just in case. Just in case. I feel like I forgot to. No, it looks like it's fine. So one day it will finish grading. So I will move on to the next one while it's grading. So anybody have any questions about the first problem? Still waiting. Oh, it's grading. Yes?
I have a question. Yeah. I tried to run the program in Java and it's saying exception in Fred main when I try to do an input on it.
Oh, that's strange. Can you share your code out? Let's take a look.
Yeah. All right, I think I'm sharing it.
Okay. Oh, looks like number 11 timed out, so we need a slightly better method. But I'm going to. Okay, the text is really small. It's like size like 0.001. So if you have an exception, first thing you have to do is click on the bottom link, the very bottom one down there. It will point you to the line that occurred. So you could see that our issue was it was the one that I was telling you about, s dot. All right, it looks like the solution is to put in dot next line.
Oh, in there?
Yeah. Yeah. So no, you you keep char, but you change the next line into dot next. So yeah. So dot next.
For that or for here? I think it works.
Okay. So this program should work for 1 through 10. I tried to do it in the interest of time. I didn't do the more complicated version. There is a way you could do this in ON time. There's actually, if you think about it, right, there's still a lot of repetitive work that has to be done, especially since like if you, especially since you discard the very first character of your string and then you just redo it, you recalculate everything. So there is a, so if instead of thinking about it as a string of G's and H's, you might get really far if you think of it as, let's say not a, like an array of strings, but rather a series of indexes. Like, one, like if you make two different arrays and you store the indexes of G and H's, that might help you, especially because then you could look at sequential things. So I will leave that as an exercise for you. So yeah, yeah. So one thing that you can do is if your program works, you could test it against other output to make sure it works, because at least you have a working program. That's important. Okay, so now we have air conditioning or conditioning, as they call it. It says Farmer John's and cows are very particular about the room temperature in their barn. Okay, looks like I have to move this. Some of them like to be on the cooler side, and while others prefer more warm. Okay, yeah. So to answer everybody's question, I made a slight mistake. It should have been, instead of next line for scanner, it should have been dot next. So yeah. And again, there's one that timed out. This one is the really long one. So the algorithm works in principle. It's just it's a O of n squared is a little bit difficult to deal with, especially in Java or Python. So maybe one thing that you could do is look into ways to make it faster. There is an O of n solution to this. I just didn't because it's talk about it because it's a little bit involved. But that might be one thing that you do to practice it, because there's other ways to solve this that don't involve this method. Like looking at the indexes of the string, like in looking at it in terms like through the lens of indexes rather than like this whole string itself. So we have this one looks a little bit more complicated, but the solution is actually a little bit easier. So Farmer John's and cows are very particular about the room temperature, blah, blah, blah. They have n stalls numbered 1 through n containing a single cow. The ith cow prefers the temperature of her stall to be pi, and right now her temperature of the stall is ti. In order to make sure each cow is comfortable, Farmer John installs a new air conditioning system that is controlled in an interesting way. He could ask it to raise or decrease the temperature in a consecutive series of stalls by 1 unit. But yeah, he could do that. It could actually be as short as a single stall. It says, please help Farmer John determine the minimum number of commands he needs to send his new air conditioning system. So the idea behind this, right, is that we want to be able to, I mean, like, they're asking for the minimum because, like, they're asking for the minimum. So it can't be like technically you could run the air conditioning on this room 3 times and this one once and this one once and this one 3 times, but obviously that's not the minimum. So this requires a little bit of thought. But if you do a little bit of math and you're like you have to find relationships, basically. Try multiple methods. Try solving the question. In fact, it might help if you write a slower version of it and find like connections, because your slower version might not work at all, perhaps, or it might not work on all of these cases, but it could be really useful, and like you come up with a test case and it solves a problem for you. So at least it produces the correct answer, just like the solution here produces the correct answer. It just can't run on number 11 because it's a little bit slow. This one, it's your test program might be a little bit slow, but at least you could find these connections. So one thing that I found was that you have to look for problem children. So like here, our problem children are these 4, and these 4, like number 1 is as we would say, a good boy, because there's no, we don't have to change it. But these we do have to. So it turns out if you try running this for long enough, you start to see some connections. So here we have 5, 2. You have to find the absolute difference, which is basically this top minus bottom and take math.abs. So if this is row number 1, this is row number 2, we'll just call the next row row number 3. We'll call it D for difference. We'll just call it the D row. So here we find 0, and then we have 3, and then we have 1, 1, and 3. We have that. So basically, we have now what we have to do is find the absolute difference between each of these, between the numbers. Yeah, that's what we do. We find the absolute difference between the numbers. We have 3, we have 1, there's 1, then there's 3. And then so you basically subtract it. What we do is you also want to subtract the first and last numbers too. So that, yeah. And you also want to have an extra 0 here. You want to have that 3 play a role too. So these are one of the things that you kind of have to, like, if you're like, how did this guy get it? You have to look at basically you have to try this problem and look for patterns that you see. Because not all problems are like this, but a couple of them are. So if you find that kind of pattern, you're like, oh yeah, this could be really easy. A lot of the most terrifying problems here aren't actually that hard because there are a couple of problems. I remember I did USACO back in 2018. In 2018, they had a silver question that I actually saw that you could actually solve with one line of code. So which is very impressive. It's it's one line of code. So don't exclude the fact that there could be very simple answers to your questions. So I will go ahead and write that. So the lucky thing is that for us, it looks like our maximum value is, what is our maximum value? Okay, a maximum value can be something. I don't think they specify it here. Is yeah. But if you think about it, it's basically O of n. Because we loop through the array once to find d of I, and then we do a little bit of subtraction, and then we loop through it again. It's technically 2n, but like, unless we're squaring it, it doesn't make a difference. So I'm going to make this one. This one will be a little bit quicker. There's no nested for loops. So we have public, class, air, Cownditioning. We have public static void string of args. It looks like our samples, it looks like there's only 2 lines. So we could just use scanner. I actually don't know how large n can get up to. They don't ever specify it. It looks like at the bottom it says they could satisfy n of less than or equal to 100,000. So I guess our maximum is 100,000. We will make a scanner. I know in my classes I've taught people to use buffered reader, but you could also use scanner if the input is not that large. Like this input is like 3 lines. So I mean, if it was like 800 lines, and you would have to reconsider it. But yeah, let me turn on the syntax highlighting. Let me copy and let me save this. System.in. You get n. Then we will just make an array. But we'll make our first row array. So we'll just call that A. And then we'll make another array right below it. And then for each, we will do A of I equals S dot next. And so all we're doing is reading the input. So if you like to use buffered reader, then you can obviously use it. And then I'm just going to copy and paste E over here, and that should do the trick. And then I will set up a test file just so what happened last time doesn't happen again. Where I'm like, oh, there's an error in this, but I didn't catch it until I tried running it. So I made the file. Oh, I need to put my imports at the top. Looks like it all seemed to work. So we need a new array up here. I'll just call it D, that takes all of the differences. So remember, we want to eventually sum all of the differences, or sorry, sum all of the differences of the differences. Like it's kind of like it's on a different level. Like so you would actually want to start this at n equals 1, because the idea is that if remember, the idea was that if we have a bunch of differences, I think the one above was like 0, 3, 3, 1, 1, and 3. They would want to take the difference of the very first number so that it gets included too. We don't want to start on the second one. We also want to include the one at the very end because, like, again, we don't want it to feel left out. So that's why the length of this one would have to be 2 plus 2. So it's a little bit longer. So when we do it, we would have to shift everything up by 1. So when we put in our differences, we would have to shift it. 4 I equals 0, I is less than n, I plus plus, of d of I plus 1, because remember, we're shifting it, we're including these empty zeros at the very beginning, empty 0 at the very end, is equal to a of I minus b of I. I suppose you could actually do a math dot abs, although it shouldn't matter in the end, but I guess you can if you would like. Let me erase that. Okay. Yeah, there we go. We have that. And then what we do is we look at the answer. So we sum together everything and then you divide it by 2. That's basically how you do it. So I will int answer equals 0 for int I equals 0. I is less than or equal to n. I plus plus. Basically, when you do this, be very careful about how you do this. Excuse me, because you will see that like this is all less than n, less than n. This starts at 0 and it goes up to and including n. So just be very careful when you do this. So it says our answer is going to be math.abs d of I minus d of I plus 1. And you can see we started at 0 because we would like to capture that first number, obviously. We went all the way up to and including n. So we would be able to, we would be, excuse me, we would be able to catch that last number. We do system.out.println, we do answer divided by 2. So now it's all very simple. Looks like my program spit out 5. Looks like that's the right answer. I'm now going to submit this program. I have the program still on the screen for you to enjoy. And then you could check it. All right, so it looks like all 10 of them work for this one. So does anyone have any questions about this? No questions? Okay, so just a couple of things about these two questions. The first one, you could see that our the first one that you could see that we got a huge performance gain by going from n cubed to n squared using a simple trick, which is to like you have to reconsider what does it mean for us to like loop through this string. How do we figure this out? Like how do we figure out how many like cows are in this array, or like how do we figure out how many G's and H's are there, and how do we avoid recounting all of them? And I feel like there's a little bit of room for improvement. You could, of course, use indices like indexes rather than the individual instead of dealing with like the string. Because again, if you have a because again, you're just recounting all of the recounting all of the because we are not recounting them when we are looping through them the second time, but we are recounting them every time when we loop through them in the outer loop again. So that's a little bit of a waste of time. That one is a little bit harder to fix. So if you're able to, so one of the exercises I guess for you to would be to find a different way that does not involve having that outer loop. There is an O of N solution, but I just gave this one to you because it's a little bit easier to understand. And look, 10 of them work. On this one is just looking for patterns. There is a much simpler solution to this than it appears. So you might want to write a simple program to deal with some kinds of like small inputs, figure out a pattern from it, and then use it to write an answer. So it's not always a bad idea to write the simplest program you could think of, because that could be a jumping off point for more complicated programs. So like just because it doesn't reach all of the test cases doesn't mean that it's a complete failure. You can still learn from it and you can still use it. And I don't learn from it as like you learn from your mistakes, more like, oh, I'm learning what kinds of patterns that I'm seeing here and I'm applying it. Because again, these are patterns. These are basically patterns. So yeah, so they basically search for patterns, I think is the best way to put it. All right, does anybody have any questions? All right, so good work today. I know, sorry about the technical difficulties at the very beginning. That was not intentional. Hopefully starting from tomorrow it gets a little bit better. So again, we have this class again tomorrow at the exact same time. So yeah, so don't miss it. I'll go over two other problems and then I don't, who's coming on Wednesday? I think I might be coming in on Wednesday again. Let's see. Oh yeah, I am coming in on Wednesday. So you'll see me for 3 days and it'll be Solomon teacher. So yeah, so have a wonderful evening. Continue to work on it and I will see you later.
Thank you. Have a nice day.
Oh, thank you. You too.